All right, looks like we have a good group here with us today. So hi everyone and welcome to our brown bag session on security. My name is Lisa Carnes and I'm one of our CSMs at Sumo Logic, and I'm going to get things kicked off here for us today. If you haven't been to one of our sessions before, we launched this series earlier in April, and we have them on the second, the third, and the fourth Tuesday of every month. And they're designed to provide opportunities for our customers to spend time with us in a more intimate, informal setting so that you can learn from one of our key technical experts here. And so today we have, for our security session, one of our senior threat research engineers, Anton, and he's going to be covering threat detection and hunting with Sumo Logic. And so I have opened up the chat, and of course, Q&A is always available. So if you have any questions throughout this time, just feel free to put them in there. I'll try and help answer them as I can. And if not, we'll have Anton do it. So without further ado, Anton, go ahead and take it away. Thank you.
Yeah, thanks so much, Lisa, and thanks everyone for joining. I know in these days, an hour of your time is worth its weight in gold, so really appreciate everyone spending the hour with us. So yeah, I'm a threat research engineer here with Sumo, and we'll just go ahead and kind of dive right in. So I just wanted to kind of start the session by situating ourselves a little bit. Obviously, as like SOC analysts, engineers, us folks on the defensive end of the InfoSec spectrum, we are often asked to kind of like find threats in the environment. And in these cases, sometimes I like to think of the environment as like a vast ocean where, parts of it are peaceful and you have your fish kind of swimming around beautifully. And then other parts are kind of teeming with sharks and other fish that want to eat you, that want to like bite your limbs and take chunks off you. And through experience, I always found that the toughest part of this in the context of threat detection and threat hunting is just kind of getting started. How do you approach such a vast topic? How do you approach this like vast ocean of threats? And the proverbial ocean is filled with threats, and the real ocean is as well. And what's on the slide is just a little snippet of the cloud native landscape. And this is just for Kubernetes service providers. So this doesn't take into account, hybrid environments, on-premises components, other cloud infrastructure that we all have. And I kind of focus on this endless ocean of threats to drive a point home. And that's in order to begin doing this kind of stuff in your organization, to begin threat hunting and building like the advanced use cases, you kind of need a game plan or you're going to get overwhelmed super quickly. So given this kind of like dynamic that I just outlined, what are some of the tools that we could use to kind of help us sharpen focus here and get started? So one of the tools that I love to use is the pyramid of pain. And the pyramid of pain can help us focus our detection efforts. And although this particular image, it kind of gets thrown out a lot in InfoSec circles. And I find that some folks tend to kind of misinterpret it a little bit. The pyramid itself is illustrative from the point of view of a threat actor. So that is, if you put yourself in the, so to speak, evil shoes of a hacker, from their point of view, things like hash values, IP addresses, domain names, those things are relatively simple for them to change. However, things like tools, techniques, tactics, procedures are much tougher for them to change. So if you're a threat actor and your infrastructure gets burned, the blue team finds it, blocks your IP address or whatever, rotating that for them is pretty easy. However, changing how you operate, how they operate, how the threat actor / hacker operates is much more difficult. So given this kind of dynamic, as defenders, it's important for us to focus on the kind of top of this pyramid when thinking about threat detection. So what this means in practice is that rather than focusing on looking for specific hash values, IP addresses, et cetera, in our environments, what we should be doing is focusing on tools, techniques, and procedures, so the top of this pyramid. So this doesn't mean, though, that we should just give up looking for static IOCs. Those have like a ton of value, and they're very valuable and they work. But if you're looking for things to automate or play with the AI and ChatGPT and all that stuff, focusing on the lower end of this pyramid is a great start with a more human touch applied towards the top of it. So in this regard, what we often hear is focus on the technique, not the tool. And this is a phrase that I kind of hear thrown around quite a bit, but it's much easier to say it from a podium on a stage or a Zoom giving a PowerPoint than it is to actually do from the point of view of a SOC analyst that's sitting in a chair that is tasked with finding this kind of stuff and is kind of staring at a blank search bar at their SIEM. So what I want to do is kind of unpack this dynamic a little bit. So at this point, we're bought into the pyramid of pain. We're ready to detect the technique and not the tool. That's awesome. So where do we start with this kind of stuff? And many folks here have a kind of knee-jerk reaction to look at the attack matrix and kind of start working their way through each square in order to build up their detective coverage. And I fully understand this, and I realize it, and I see the need to have comprehensive attack coverage. I do work at a SIEM vendor, but there are a lot of kind of pitfalls to this kind of approach. Chief among them is that it doesn't really address unique organizational parameters in network design. It also does not take into account risk areas within the organization, and it kind of lacks any prioritization or applicability. So there's things in the attack matrix that, for whatever reason, may not apply to your particular environment. Here, it's really important to recall that MITRE ATT&CK was designed as a reference model in order to provide a common language set across teams. It was never designed to measure organizational detection efficacy. And the way I like to think about this is that if you were to approach kind of like wanting to learn a new language, you probably would learn it through practicing or instruction, moving your way towards having a conversational understanding of it. You wouldn't open the dictionary and learn one word at a time. I think that's the kind of difference between learning a vocabulary versus learning to speak a new language. And I think that this dynamic applies to, the MITRE ATT&CK bingo game that we all play, trying to measure our detections towards MITRE ATT&CK. So kind of frustratingly for me, what I think is the most useful part of attack is not used often enough, and that's the data source component within MITRE ATT&CK. So here I'm crunching the MITRE ATT&CK data a little bit. MITRE provides like a JSON file with all its techniques and procedures and all that. And if we look at which data source component detects the most techniques, by doing this, you can kind of help prioritize both detection and collection efforts as well. And this kind of provides you a very practical starting point when you're looking and facing that proverbial kind of ocean of threats that I covered at the start of this presentation. So if we look at the attack data sources, and I know it's kind of hard to see in the slide, but the command execution and process creation categories provide far and away the most coverage when covering various techniques in the MITRE ATT&CK framework. So here, just important to keep in mind that this is kind of like a numerical measurement, and again, it doesn't take into account specific areas of risk. Here, kind of a good example of a technique that doesn't fit nicely into this model is something like business email compromise. That's a huge problem for organizations, but the telemetry data point from it is only one technique, so it wouldn't be represented when you're counting MITRE data sources in this manner. So from the previous slides, we kind of noted that command execution and process creation are really important MITRE categories. So kind of let's unpack this a little bit and look at a more practical example with command line obfuscation. So what we can do here is do some really quick and dirty threat intelligence work. And here I'm utilizing the really amazing tool called orkl.eu. If you haven't tried the search engine, give it a shot. What it does is it categorizes a bunch of threat intel reports into searchable text, and you could download the PDF here as well. And they have a pretty comprehensive library, so it's a really great resource. So what we do here is just search for command line obfuscation, and what we find is that this technique is used for things like cobalt strike, lateral movement, and is used by threat groups such as Conti and Fin7. So worth looking at. It's used by threat groups that target a wide range of industries. So definitely something that you should be looking at. So at this point, we have kind of all the elements we need to go ahead and start building some detections out, because we prioritized the collection of this telemetry since we know that it covers a broad swath of MITRE attack techniques. We have this telemetry available in our SIEM and in Cloud SIEM, and we looked at our existing coverage and have made some risk-based decisions that the existing coverage could use a little work and needs some beefing up. So kind of diving into the technical parts of this, the actual queries and how you actually begin to tackle some of this stuff. There are kind of a lot of different ways to detect something like command line obfuscation. One of my personal favorite ways to do it is through what are known as qualifier queries. And what this does is not a direct match looking for, thing A or thing B, but rather it uses qualifiers, which are kind of like if statements to make the query more it depends style. So here on the screen is an example of a qualifier query that has some if statements, and what they do is they match on special characters that are found within the command line, and results are only returned to you if a combination of those special characters are found. So the cool part about writing queries in this manner is that they could be adopted to your specific environments. And as we all know, different tooling within the environments often produce command lines that look really weird, that can vary depending on kind of what environment you're in and what tools you're running. Another approach that we could take here is assigning a score to each of the characters, each of the special characters that were matched, and returning results only when that score reaches a certain threshold or crosses a certain threshold. And keep an eye out for our threat research blogs. We have one coming up that goes into some detail about this technique and querying like this. So looking at another type of command line hunt, we could go ahead and make a really simple Cloud SIEM signal that just looks for a command line that is over a certain length. So the idea here is that you go in your environment, you baseline it, and you say, okay, how long are my command lines? And you find that, okay, the longest command line in my environment happens to be 7,000 characters. So you make the assumption that anything longer than that is at least worth looking at. If it isn't outright malicious, it's worthy of bubbling up to your attention a little bit. So then we could go ahead and take our two searches and combine them into an insight where analysts can take notes, view a timeline of events. And the real power here is that these signals combine into an insight when they're generated from the same entity and have a severity score over 12. So here, think of the severity as another tool in your tool belt that you can use, another knob that you can dial up and down to bubble up malicious activity. And also recall here that you have the ability to take a search that you run in Cloud Security Analytics and turn it into a signal for Cloud SIEM, where you can include it in insights or build custom insights. So these are really powerful tools, a lot of options, a lot of areas for you to tweak up and down in order to kind of like bubble up malicious activity that is suited to your particular environments. So it may sound a little bit silly at first, but a lot of advanced intrusions and APT groups run whoami upon gaining initial access. I know it seems like a really simple command that exists across operating systems, but they run this command to see what level of permissions they have and what user context that their beacon, shell, payload, whatever you have, may be living in. So this is a really important step for them. They need to kind of do it in order to understand what privileges they have to the system that they're attacking. So as a detection engineer or SOC analyst, detecting whoami is kind of a little bit of a vanilla use case. So I wanted to kind of spice it up a little bit using some Cloud SIEM features here. So in this slide, we are using a chain rule that exists in Cloud SIEM, and the chain rule itself has relatively simple logic detecting whoami across multiple operating systems. So Windows, Linux, and Mac OS. That's what 1, 2, 3 corresponds to here on the slide. And something that I want to draw attention to is that all the command line values are being filtered on the exact same field named command line. And this is across operating systems and across products as well. And I feel like this is a really good example of our comprehensive mapping features that are found in Cloud SIEM. So what this means on a practical level is that analysts don't have to worry about what a particular field is called when they're looking at different products or even different telemetry coming from the same product. So on Windows, your command line could be coming from a 4688 standard security log event. It could be coming from sysmon event ID 1 and your EDR as well. So all this gets normalized. Analysts don't have to, pull their hair out to look at all the different variations of what command line is called across different products. We kind of take care of that for you. And this is what the results of this alert looks like. You see the base image, so what particular executable got executed. We see the 3 different host names involved. We see the parent image, so where did this who am I come from? If you're looking at something like who am I, if it comes from a command prompt, that might be normal. But if it comes from something like Word or Outlook, that might be a little bit less normal. And also we see a key from Laurel logs. And Laurel, I'll call out specifically here, if you are kind of struggling to log your Linux systems, and if you're struggling to make sense of audit D logs, Laurel is a really great tool that makes them readable. It stitches them together into a nice JSON format. Again, if you look at our threat research blogs, specifically the Cloud Credential series that we have put out, we go into Laurel quite a bit depth. So of course, if you've ever actually tried to do this and you've actually tried to hunt for who am I in your environment, it probably comes as no surprise that it occurs pretty frequently as normal business operations in most environments that I've seen anyway. So what if you could kind of baseline this behavior for a set period of time and only alert on new execution? So this user has not run who am I for X amount of days or X amount of weeks, and all of a sudden they're doing that. This is something that our first seen rule type does for you. And to build this rule, it's all done in a GUI. You don't have to mess with queries or timestamps or anything like that. So the logic that comes across in the screenshot looks fairly simple, but behind the scenes, what the rule is doing and the power that it gives you is pretty complex. So I highly recommend that if you're struggling to filter noise down on certain things that occur frequently in your environment, those are really great candidates for things like first seen rules. So earlier, I talked a little bit about measuring command line length as a really good starting point for a threat hunt. And this is a use case that our outlier rules kind of take to the next level, very similar to first seen, where they take the pain out of baselining work and allow you to build a fairly complex data model in a very simple UI. So in this example, we're running a baseline for 15 days with a 90-day retention, and we have a threshold set for command line length that comes out of a PowerShell process. If you ever looked at threat intel reports and any threat groups that utilize PowerShell, usually those PowerShell command lines are really long. They have encoded bytes in them and things like that. So when this command line length exceeds the threshold, a signal is triggered. And I know that, at least for us internally, and we've heard this from some customers as well, that there tends to be a mental link between outlier rules and network type telemetry. So be it proxies, firewalls, things like that. And those devices are great for outlier rules, definitely use cases there. However, I really encourage you to tinker around with these rules, play around with them and dive in, because there's other types of data sources, including host-based data sources, that lend themselves very well to both first seen and outlier rules. So far we've kind of focused quite a bit on the command line. So I wanted to kind of shift gears a little bit and touch on some more advanced techniques and look at their respective detection strategies as well. So this is kind of like one of my personal favorite threat detection vectors, and that is credential access. And credential access, especially when it comes to like weaker areas of credential access. And when folks hear credential access, usually the next thing that comes to mind is a really delicious looking kiwi and the Mimikatz tool. And I love Mimikatz as well. Everyone I know loves Mimikatz. It's a very like paradigmatic tool in our industry. However, there's a lot of other credential weak spots on endpoints, and these can include file shares, flat files that contain credentials, your standard password.txt file that lives on the user's desktop, things like browser cookies and various cloud tokens. And I don't really have time to deep dive into each one of these topics. Our threat research blog goes into really big detail about each one of these areas. So if these areas kind of strike a chord with you and you think like, oh yeah, this is might be applicable to my environment as well, take a look at our blogs. They really walk you through what data sources you need, how to wrangle this kind of stuff, detection strategies as well. I do, however, want to spend some time focusing on browser cookies specifically, as I think that this is a particularly effective technique from an attacker's perspective. And I have a demo lined up here, so I'll show you what this cookie theft, browser cookie theft looks like from an attacker's point of view. And this is a recorded demo, so I'll tee it up a little bit before it starts. So basically what we have is a victim host and the attacker host. And the victim host is logged into an Azure portal, and the attacker has control of that victim machine. And what the attacker is going to do is start Chrome and then send a payload to Chrome to return the cookies. The attacker will then exfiltrate those cookies to their machine where they'll get loaded on, and then they'll steal that authenticated session. So hopefully the demo kind of makes sense here. Let me just start it. All right. So we are on the victim host, and this is where we're going to be stealing the Azure session from. And we're going to be doing this manually without any additional tools. So here we're going to start Chrome with a debugging port enabled. And once we do, we'll see Chrome pop up. We'll then go ahead and browse to Azure, where we have an authenticated session. We're logged in with a test account. All's good. And then what we're going to do is curl that debugging port that we just started to grab a WebSocket URL. And then we're just going to use a WebSocket client to go ahead and connect to that WebSocket URL. And then we're just going to tell Chrome, hey, please give us your cookies, return the cookies to us. And we'll just do that with a quick request here, which is called network get all cookies. Makes sense. And once we do that, Chrome gives us the cookies, and then here the attacker will copy paste them, upload them to OneDrive, exfiltrate them through some means. And then this is the victim machine. So here we are not logged in. Oh, I apologize. The attacker machine. Sorry, that's a big miss on my part. So this is where we're going to be loading the cookies into. So we're going to be using the Cookie Bureau extension here. Once we open it up, we'll go to the cookie editor, and we will browse to the JSON file that contains the cookies that we stole from the victim machine. And once we do that, we'll load them in here. And then once we do it, it should say cookies imported. Yep, we're good to go. So now when we go back to our Azure, which is unauthenticated, we'll refresh, and Azure will complain a little bit here. I think this is because of the timestamp difference, but once we hit try again, no problem. Azure lets us through. And this also, I should note, is depending on how your conditional access is set up in Azure, this could be an MFA bypass as well. So cookie theft, extremely dangerous. We didn't interact with LSAS to make EDR angry or anything like that. We use tools that are typically found on a developer's workstation, so we didn't have to drop anything extra to disk or anything like that. So I think that this is a quick exercise here that I feel that a lot of defensive-oriented teams miss, and that's looking at things from a threat actor point of view. So let's go ahead together and look at cookie theft through this lens, through the lens of a threat actor, a hacker, a nefarious actor, what have you. So we'll pretend that we're an attacker that has a beacon or shell on a host, and we have a choice of either dumping LSAS memory with a tool like Mimikatz, or stealing a web session cookie, similar to how we just demonstrated. So we'll look at the first row there, which is EDR controls. EDR, obviously, endpoint detection and response. And these controls have, over the years, actually become very good at detecting in-memory credential theft from the LSAS process. There's also, in Windows world, there's a lot of hardening options available for this kind of thing too. So it may, dumping LSAS may not be as easy as it sounds from a threat actor point of view. The second row there for logging, if we look at this technique, these two techniques from a logging standpoint, generally speaking, security products and detection efforts, there's a lot of stuff out there for LSAS credential dumping. If you Google, LSAS credential dumping Sigma for Sigma rules, there's a whole bunch that come out. That's not really the case for cookie theft. There's just less detections out there for this kind of thing. In terms of reward, so meaning like, what do you get as a threat actor for doing all this work? If you look at it through that lens, stolen browser cookies, as we saw from the demo, give you an authenticated session to wherever that browser was authenticated to. Whereas LSAS memory, especially these days in 2023, may or may not contain clear text credentials. More often than not, that's not the case. That LSAS memory dumps do not really contain clear text creds these days. So in terms of reward, you're getting a lot. You're getting a lot of bang for your buck as a threat actor using this kind of technique. And if we look at the final point there, exfiltration options, cookies are just a JSON file. So EDRs, your DLP products, what have you, most likely will not flag on that kind of thing. Whereas if you drop an LSAS memory dump to disk, usually, more often than not, either DLP or an EDR will be kind of all over you. So this is a good example of why this technique is, at least in my head, in my mind, in my opinion, a very attractive threat vector for a threat actor to take. And if we think of this through like a cloud lens, think of how your users, administrators, developers, etc., go ahead and access cloud environments. It's usually through a browser or a terminal of some kind. So given that dynamic, defending against cookie theft, cloud token theft, and things like that becomes a really critical thing, a really important thing for you to do. So digging slightly deeper into browser cookie theft, these are some of the event IDs that we need, or at least can use to help us as defenders wrangle this technique. And again, our blogs kind of go over this in great detail. So some of the events that you need are object auditing events, be it on Linux or Windows. In Windows, this is your SACL auditing, your 4663 type events that tell you when a file was accessed and what process accessed that particular file. Process events that I've been harping on so much during this presentation are also important here. These include things like parent process and command line values for the best results. Network events are also important, particularly if those network events tie in process information as well, so you get to see which particular process made a particular network connection. So sysmon event ID 3 is a great example here. Process injection events are also important. Things like create remote thread or process access in sysmon are good examples. For detection strategies, we could use the network events to flag on network connections that are coming into the browser instead of the normal network connections that occur outgoing from the browser. That's abnormal behavior that we can flag on. We could also use SACLs to alert us when a non-browser process touches history or bookmark or cookie files. And as shown in the previous slide, we can alert on the command line as well. And finally, we could look at strange or abnormal processes injecting into our browser processes. And the final step here, this is something else that I think that defensive teams miss sometimes, is the validation piece. How do you validate that your alert is actually working as intended? And it's very hard to do so to perform that validation step manually. Sometimes you need tools that help you do that. I know there's a big kind of debate about this, whether offensive security tools that are available freely are net positive or net negative. I don't want to get into that debate. However, I will say that the tools are there for you to use. You can compile them, download them off GitHub after you do your source code review and all that. So tools like White Chocolate Macadamia Nut, I know it's a funny tool name, but it automates the process of cookie theft for you. So what I showed in the demo through the manual steps, White Chocolate Macadamia Nut does that for you automatically. Sharp Chrome is another tool that can help you validate this kind of stuff. It just enumerates cookies and history and all that good stuff. And another tool here is Seatbelt. Seatbelt performs general system enumeration, but it includes browser enumeration as well. So again, these are tools that are available that you can download, that you can compile yourself, run in a safe environment, and work towards validating your alerting strategies. So from the demo, we kind of, hopefully you get a good sense of the danger of cookie theft and how it can be pulled off using tools that are just found on a developer's workstation or tools like White Chocolate Macadamia Nut. Luckily for us though, that detection hope, it's not lost. There's still artifacts that we can detect on. So this alert is just showing the Chromium process, so Edge or Chrome, being started with that debugging port. And if you're a Cloud SIEM customer, this rule is already deployed to your tenant. It's already there. So this is just one technique that we can use to alert on something like this. And I think this ties in the importance of command line auditing that I harped on so much at the start of this presentation, in that even though we're looking at something like cookie theft, and even though the command line is typically not the number one element, not the number one data point that we could use to detect it, we could still use process events to help detect techniques that don't directly link to it. So even though I just spent some time showing you our awesome alert, browser cookie theft is kind of one of those things and one of those techniques that's a little bit difficult to alert on and act on when you just see the event in isolation. So let's look at the alert that I just showed through the lens of perhaps a newer SOC analyst, or even an intermediate or senior SOC analyst. I think every SOC analyst can benefit from this kind of thing. What do they see when they receive this kind of alert? They might, rightfully and understandably, think that developers will sometimes do this kind of browser activity as part of their normal operation. And this makes sense, right? Because the debugging port, the developers debug things, this makes sense. They could also think that this is normal browser behavior. If you've ever dug through the maze of Chromium flags, it's easy to see why it's so overwhelming. There's literally hundreds of them. They could also maybe not see any other strange activity coming from the host. And finally, the company that they're monitoring might not ingest cloud authentication data at all. So even if the analyst did believe that, hey, something weird is going on this host and maybe a threat actor is trying to steal cookies, they would kind of run into a dead end in their investigation on the other side of it. They can't have the right telemetry to link what's happening on the host to what's happening on their cloud provider. So now let's add a little bit more context to the same event, where our SOC analyst sees that the parent command line used to launch that Chrome process with the debugging port enabled came with something like an exceedingly long command line. They could also see maybe a cloud credential file was accessed during the execution. So the threat actor tried to grab a cloud credential file. That didn't give them the access they wanted, so they turned to the Chrome cookies. They could also see an event that showed an incoming network connection to Chrome, and on top of that, they can understand the first scene context. So in other words, they could see that, hey, this activity or this user, this host, however the first scene rule is configured, has not done this activity before since the baseline. So this is abnormal. So now the alert goes from low to medium confidence to a fairly high confidence alert. When we combine all these things like a long command line, other types of cloud creds being accessed, the various network events that occur combined with that temporal element, that alert gets shifted from a low confidence to a more higher confidence alert. So what this means is that, and this is the final slide I have. So what I'm trying to get across is that SOC analysts have a lot to deal with. They have a lot on their plate, and all these techniques that I covered have a lot of moving pieces to them with different strands of telemetry. So some of that telemetry might be coming from a host, some from the cloud, maybe an app. So these are all telemetry elements that SOC analysts need to link, and this is something that we work on quite a bit. And this screenshot here is our entity graph, which shows you what a particular user did in a very easy to digest graphical format. So the more context that we are able to provide, and that means we as a vendor, like Sumo provides to the SOC analyst, combined with the more telemetry that we're able to provide to them, the more we're able to make available to them, the more success they will have, the more data they'll have to make more comprehensive decisions. And I think this is where I will leave it. So thank you very much.
Thank you, Anton. That was awesome. So we have some time for questions. If you guys want to raise your hand and I can take you off of mute, you can go ahead and ask your questions.
Yeah, please, please.
Yeah, okay, we do have a hand raised. Okay. Actually, this went away. Can you keep your hand raised so I can see who it was? I don't know who raised their hand. Or maybe it was a mistake.
It could be.
Anyone want to ask a question? Okay, it seems that we do not have anyone who has a question. That's okay. Oh, wait. Okay, they said no. It got me excited. I was like,
Fair
oh,
enough. Fair enough. Yeah.
it says no questions. Okay. Alrighty. Well, really appreciate everyone's time today. And thank you to Anton for an amazing presentation. Oh, wait, hold on. We have one. Okay.
Yeah.
For application hosted in GCP, what is the source to use for threat intelligence?
So for applications hosted in GCP, I think it would depend on the type of app. As far as I know, GCP doesn't provide threat intel. So you would have to look at a vendor or a provider for that threat intel that targets the application that you're looking at. It usually depends on what the app is, what the service you're looking at. So yeah, sorry, a bit of a non-answer, but that's typically how I've seen it done. Usually, I know Azure is a little bit different, but cloud providers like AWS and GCP don't have their own kind of like threat intel function, as far as I know.
The follow-up to that is it is in a MERN stack, MERN stack.
I'll be honest, I don't know what that is. I'm sorry.
Prakash, I can take you off mute if you want to explain more context. All right, go ahead, Prakash. Prakash, are you there? Okay, well, feel free to chime in. I'll keep you not muted if you want to give more context. Anyone else have any questions for Anton? While he's here, we still have him for 18 minutes. Prakash said MERN stands for Mongo, React, and Node.js.
Oh, okay. Yeah. So if you're that, I don't think GCP has any built-in threat intel for that kind of thing. It depends on what would be the way I would approach it is looking at what's actually internet exposed, and then looking at what type of intel exists for that service. But yeah, that would be like an intel provider that would give you that threat intel. I don't think GCP would. I know like for Azure, Azure has like risky IPs and things like that. Like Microsoft has a threat intel function that feeds back into Azure. I don't know if Google has something like that. So yeah, sorry, I apologize. I know it's a non-answer, but I don't think there's any Google service, or at least not a GCP service specifically that will give you threat intel.
Okay, any other questions from the group? Prakash says thanks.
Yeah, my pleasure. Yeah, so I apologize again. It probably wasn't the answer that you were looking for, but.
All right, well, if there's no other questions, we can go ahead and wrap this up. All of our sessions are recorded and they are on our YouTube page, which actually, let me just grab that link for you and I'll put it in the chat for everyone. So this one should be up there probably in the next couple days once I get the recording and send it to the guy that puts it on there. All right. Thank you so much, everyone. Have a good rest of your day. And thank you, Anton.
Thank you. My pleasure.